we'll be using Java code eventually. So yeah, today we are starting on the next module, which is databases and SQL. Programmatic access, of course, is going to be part of that when we connect with Java. That's a couple of weeks away, especially in your actual project. Instead, today we're going to start by looking at SQL, introducing that as a language. Then we'll go into database design, and then we'll get into programmatic access to databases. Just up front here, though, administrivia, that if you hopefully we've been getting good feedback from Plant CS participants. If you have had trouble, finding a partner or making connections in the course or whatever, or staying on task or whatever, Plant CS may be a good solution for you. Remember that they do have a bi-weekly meet. Every other week they meet. Ryan's next meeting is tomorrow at 2 p.m. And Perul is meeting everybody on Monday at 6 p.m. If you'd like to join them, go ahead and check out the link on the Canvas page. Right? But otherwise, to get to SQL, what I want to do is I want to motivate this by looking at the original video game database that, or data, I should say, that you worked with in your first assignment. It was represented as a CSV file. A CSV file is a flat file. Flat because it's taking the data model, this complex relational data model, and it's essentially projecting it down onto one plane. So it's kind of like when you take a three-dimensional object, right? A cube. When you project it down onto 2 dimensions, then it loses a dimension, right? It flattens it. That's the idea. And unfortunately, it's pretty limited, right? There's a lot of repetition here, right? Lego Star Wars was released on 4 platforms, and to model that data, that means that we had to repeat things over and over and over again. Not only that, but it's completely flat. There's really no semantic meaning to this, and so you have JSON and XML as alternatives to flat CSV files. Still, it's not it's one data representation, but it's still basically flat. Now instead of having guesswork of what is the first token, what's the second token, what's the third token, now that's clearly labeled. In other words, it has semantics. So there is more semantic meaning with JSON and with the XML version of this, where you have tags telling you what this thing is. And then with at least with XML, you can actually have what's called a schema, where it's basically a dictionary that says that to conform to this schema, it requires this formatting. And then you can validate your XML against that schema. So it's a little bit more rigor, it's a little bit more consistency. But all of these suffer from the same problem, that they're kind of flat and that it's all file-based. Right? There's repetition of data. Right? The title for Star Wars was repeated 4 times. There's potential formatting issues. If I'm expecting a year, that's going to be an integer. There's nothing to stop me in a flat file from putting a non-numerical value in there, right? 10, T-E-N, instead. There's consistency issues and integrity issues. The example that I would use here is LucasArts, right? In one record, I spell it correctly. In another record, I put in a space. That's not correct because the company name is one word. Or I use a different format, all lowercase instead of uppercase. Or I misspell it entirely, right? Conceptually, those are all the same publisher. But because of the repetition, I've introduced a potential failure point for data anomalies. That if you're just looking at it from the perspective of this is a string, then these 4 strings are different. Therefore, they have different publishers. And if I had only had one location where this publisher existed, and then I just simply made reference to it, now if I misspell it, at least it's consistently misspelled for everybody, right? Flat files suffer from all of these issues. There's also organizational problems. Because it's one file, if I have one program open up that file to process it, say like you did for your first assignment, to figure out how many platforms each game is available on, That means that no other program, system, thread, person, right, user, whatever, can come in and change that file while you're working on it because a file lock has been placed on it. Have you ever opened up a Word file and then while you're working, typing on that Word file, try to delete that file? Can you? It says no, because there's a file lock on it. It's in use. Likewise, if one thread or program or whatever comes in and starts processing data and another one comes in, it's going to be blocked until this one is done. Imagine a world in which you're only one person can use Google at a time, right? And then they have to wait for the next person and wait for the next person. No. We do not live in a sequential world like that. We live in a parallel world. There's also no security. If it's a file, then you can do whatever you want to that file. You can't have fine-grained control by like saying, well, that person can have access to these 3 tables over here, but none of the rest of it. In fact, you can get down to a point where that person can have read-only access, but they can't update or change the data. They can have access to this table and this column in that table, but nothing else. Right? That fine-grained control is not there if you just have everything in one big giant file. So the solution is, of course, an RDBMS, a relational database management system. This is the first of many acronyms that you'll have today and throughout this course and in fact, module. It's due to Edgar Codd in the 1970s, in fact, 1970 to be exact, at IBM. Right? He was working at IBM at the time. And rarely do I actually, talk about the people who did these things, but there's a mnemonic device later on to remember first, second, and third normal form. And it goes something like, everything in the table must be based on the key, the whole key, and nothing but the key, so help me Codd, right? And that's the first normal form, second normal form, and third normal form. And we'll get to that later when we start talking about database design. The key aspects are that data is stored in tables, right? And for the most part, tables, you can think of that as a spreadsheet where you've got rows and you've got columns. It's not a spreadsheet, though. Don't think of it that way. But think about it as like a table, right? Like you've got an HTML formatted table where you've got headers, and then you've got each row is a record, and you have columns of each piece of data. So tables have rows or records, right? Tables have columns. These are pieces of data or fields that belong to each record, right? So tables, right? Rows and pieces and columns. A database is typically made up of multiple tables. This is why I say that it's not really it's not really a spreadsheet. Yes, in a spreadsheet you can have multiple spreadsheets in one document, and moving tabs in one spreadsheet can make reference to another spreadsheet within the same document or externally, but it's not the same thing. If you're thinking about an office productivity software that is a database, it would be Microsoft Access, not Sheets or spreadsheets. Okay. They're typically multiple tables. Each table is related, or may be, I should say, may be related to each other in some way, right? And that's where we get the relational model. So I'll ask, have you got, most of you are taking 235 discrete math right now. You've talked about sets, certainly. Yeah. Have you talked about functions? Oh, no? Okay, the progression will eventually be that you talk about sets. Sets are just these bags of things, right? They are unique and unordered, just like a set in Java is. Then you can have functions, which are mappings between sets, set A to set B. You're mapping one element over here to another element over here. Now, one element over here could be hit by multiple elements over here. So A and B both map to 1 over here. Then it's not a one-to-one function. And now, an even greater generalization of that is a relation, where you have arbitrary mapping from one set to another set. And that's where we get the relations, right? There is one set of data that may be related to this other set of data over here through some sort of a mapping, okay? Rows are identified. Let's take a look at this picture now. I want to make sure that it's appearing online. Yeah, it looks like it's good. So here's that same video game data represented as a relational database. This is an ER diagram, an entity relation diagram. Each one of these things is an entity, and each one of these dotted lines between them is representing a relationship between them. So let's go back over here to the data and check out, let's say, LucasArts. All right, so let me fix all my misspellings there. There we go. How many games did LucasArts publish? 5? Careful. Only 3. Why? Because they're all different platforms, right? Lego Star Wars is just one game available on 4 platforms. So we've got Lego Star Wars, TIE Fighter, and X-Wing versus TIE Fighter, at least according to this data. There's lots more, of course. But let's just say that they made 3 games, right? So in other words, one publisher can publish multiple games, 3 games. Now, one game, if you just look at this, that if you look at any one game, they're over going to have one publisher. Now, in the real world, you might say, well, I know of a game that has like 3 publishers. Yeah, a lot. The bigger the game, the more AAA titles that they have, the more people that are involved, the more fingers are in the pies, and so more publishers, right? But in the model that we've chosen here is what's called a one-to-many relationship. One publisher, LucasArts, can publish many games, 3 games. Or one publisher, maybe Sega, has published no games at all. Right? Or one publisher can publish 1 game or 2 games or 3 games, or in general, many games. This relationship between these 2 entities is a one-to-many relationship. This is what we call this a chicken foot, right? This is a chicken foot diagram where it's going from 1 to many. Now, from the perspective of the game table, though, one game has 1 publisher. Right? You can model it so that there may be multiple publishers. That's I wanted to keep it simple, though. Okay. This also defines a parent-child relationship. The publisher is the parent table, and it can have as many children as it wants. Okay, including no children. They decide not to have any kids at all, right? And then we all know that. Here's another acronym that is completely unrelated to this class. Everybody knows what a DINK is, right? Double income, no kids, right? So they have lavish vacations. They're DINKs, right? Anyway, now think about this. Can a child exist without a parent? No. You need a parent to have a child. So we have a parent-child relationship. The parent has to exist before the children can exist. Likewise, if I were to delete this stuff eventually, could I delete the parent and leave those 3 children there? They would be, well, who's my publisher now, right? Now they're orphans, and we do call them orphans. And we don't want orphan data. That introduces data anomalies, right? There's consistency and integrity issues when you allow something like that. So we don't allow that. This is called a foreign key. The foreign key maps a child back to its parent. I'm a game record over here. I am Lego Star Wars, right? Who is my publisher? Oh, okay, well, here's a reference to my publisher. My publisher is 1234. 1234 is not LucasArts. Instead, what I have to do is I have to go back over to this table that I'm referencing and look up LucasArts by its publisher ID. Right? This ensures a separation of data, but a relation that you can then follow through with. Right? If you zoom in here, what does that look like right there? It's a key. This is called a primary key. Tables, I should say that records in tables are uniquely identified with primary keys, or PKs for short. References in one table, or records in one table, are referenced by another reference record in another table through foreign keys. Right? So primary keys and foreign keys. Each record in a table is uniquely identified by a primary key, or PK for short. Right? Sometimes we just say PKs. Although that has sci-fi connotations, right? PKs are like telekinesis, telekinesis, I don't know. Each records in one table may refer to a record in another table using a foreign key, or FK for short. Right. Now, we'll talk more about that when we start designing databases and best practices. Generally, you want them to be integers because you don't want to be doing string comparisons to determine is this record related to that record or not. They are made unique and they are made non-nullable, and they follow a naming convention. What naming convention did I choose here? The table is game. Its primary key is called game ID. Publisher, publisher ID. Now, you could, if you want to, go with an upper camel case convention, mirroring your objects in Java. But I've definitely chosen a lower camel casing convention for the actual fields or columns in each table. As long as you're consistent about it, do what you feel is comfortable. Old school SQL, usually they use like lowercase conventions, but then that gets tiresome on your little pinky finger trying to type the underscore all the time. So I don't do that. What's the relationship between a game and a platform? Well, here we go. Let's go back over here. So a game, Lego Star Wars, was actually published on 4 different platforms: Xbox, PS2, PC, and Mac. Right? So one game can be published on 4 different systems, 4 different platforms. Would it make sense to buy a platform that only ever had one game? Probably not, right? Unless it's like an arcade game. Okay, sure. Even there, MAMEs, or not MAME, but even there, usually the at least old school cabinets, the circuit boards, the PCBs were replaceable. Right? So you could slap new art on the side and put in a new PCB and have Galaga instead of Pac-Man. But of course, we don't care about any of that today, and we all use MAME, right? MAME? Everybody knows what MAME is? Multiple arcade emulator? Oh, okay. Never mind. Don't download pirated software, kids. Anyway, going back over here. There is a many-to-many relationship between these two things. That is realized through this intermediate table here called availability, which is also called a join table. It's joining these 2 tables together. There is a one-to-many relation from the game to the availability, and there's a many-to-one relationship to the platform. Therefore, between the game and the platform, transitively, there is a many-to-many relationship. One game can be published on multiple systems, and one platform has multiple games published on it, or it has the ability to model that idea. Yeah?
Is that how many-to-many relationships are made?
Yep, that's one way of making many-to-many relationships, and it's the way that I would suggest that you do. There are other ways of doing it, but they have consequences later. All right. So let's go ahead and start playing with this data. Once you've got the basic understanding of how a database works, that there are these multiple tables, they're related to each other, et cetera, you'll want to do some basic CRUD. So here is the basic CRUD. What is CRUD? Retrieve, update, and destroy. Those are the 4 basic operations on any piece of data, or any data structure for that matter. If you've got a map, you want to put stuff into the map. You want to take stuff out. You may want to modify stuff in the map. You may want to delete stuff in a map, or a collection, or a list, or a set, or whatever. Database, same thing. Create, retrieve, update, and destroy. Unfortunately, the keywords used in SQL don't really line up with it. It's ISUD with ISID, not as catchy as CRUD. And unfortunately, only update is the only keyword that actually corresponds to CRUD. Otherwise, you have insert, select, update, and delete. Okay. The retrieve, we'll have to use that as we go along, but I want to cover that one last because it's the big one, right? The insert, update, and delete are all pretty straightforward and pretty simple. Before we do that, though, we have to have a database, right? So if you've been watching the pre-prepared videos, hopefully you've already downloaded MySQL Workbench. MySQL Workbench is an IDE. Here, I have to open up mine. MySQL Workbench. There we go. And it's the reason that we suggest this one is because the price is right. It's free. I think that you posted that older versions work on Mac. Let's see, my version is 8.0.19. Okay, all right. All right, maybe the current version doesn't work. Maybe there's a bug with it. I don't know. But certainly this one works on Mac. I think nobody's complained about Windows not working, so I assume every version on Windows is working. Once you have this, of course, you need your database, right? And you just search for MySQL Workbench, and this pops up. You need a database so if you want to install your own server and do everything you want, you can do anything that you want with that server, go ahead. Vaya con Dios on that, but most people will not be installing an entire SQL server. I have to remember my password here. But you use your CSE credentials. If you go to cse.unl.edu/accounts, use your CSE credentials. Once you're logged in, then you can go to account settings, and you currently have, it might say that you don't have a MySQL account yet, in which case you just create one. It's the same button here. It sends you your password, which is different from your CSE login. Your login is the same, but your password is different. Keep it different. Eventually that password is going to appear in your source code, and anybody, and like all the LAs and myself, will be able to see it. Your partner will be able to see that. So don't use a password that means anything to you. You can go ahead and just use the default hexadecimal one that they send you. But in any case, I am not going to click here because I don't want to reset my password. Instead, I'm going to go ahead and go over to MySQL Workbench here. I've already set up a connection here. Let me go ahead and cancel that and show you what it looks like to edit it. And I'll bring this over here. There we go. So your host name is going to be cse.unl.edu. Don't mess with the port. Don't mess with anything else unless you really know what you're doing. But 3306 is the port for SQL, for MySQL in any case. You don't need port forwarding on SSL or anything like that. Close that. I don't store my password, but you can, of course, choose to store your password. I think, yeah, okay, I'm in. All right. Now, this is just a client. This is just connecting to my database on the servers downstairs, okay? Now, to get set up here, of course, you will need to have some data already in there. I'll show you how to do that later. But otherwise, you need to use your database. Your database is named after your login. You don't use my database. You don't have permission to do that. If you had your own server, you could name your databases whatever you want. You could name your database My Albums database. You could name a database My Star Wars Memorabilia database, right? You don't have a choice with CSE because, well, you're not administrators on CSE. They create one database that you can use. You can put as many tables in there as you want. You can put as many unrelated tables as you want. So the lab next week, there's an albums database. That can live right next to your project database, which can live right next to your video game database. It doesn't matter, right? It's all in one database, right? But to use your database, you go ahead and hit use your database. Otherwise, if you start doing queries, it's going to say no database has been selected. You only have one choice, your database. Now, if you ever get into trouble, you can, of course, drop database, your database. I'm not going to do that because I want the data in there. If you do that, then you need to recreate your database. And again, you only have access to create one database. Yeah?
You have to recreate it all from scratch?
Yeah, if you drop your database, that's it. Everything's gone. Right? So do not do that unless you actually mean to do that. And here, I'll just show you. Okay. It didn't ask me, are you absolutely sure you want to do that? It didn't say, and there is no undelete.
Can I drop other people's database? Please no.
Let's see. Is that it?
Yeah.
No. Why was I not able to drop it?
Because you didn't use it.
Access denied. Right? So
No,
little check marks with green mean everything went fine. red X's mean that didn't work. Why didn't it work? Well, you can't see it very well over here, and I can't blow it up, but access denied, because it doesn't belong to me, right? Drop database, UDB, that's our user database that contains all the information about students. Ooh, let's see how well their security works. Okay, good. I would have been getting a phone call if they allowed me access to that, and I actually did drop their database. But nope. So use my database. It doesn't exist. Unknown database cburk. Well, go ahead and create database cburk. Right now, it's already going to be created by default, I think. So you only drop your database if you really, really want to wipe everything and start clean. Okay.
How easy is it to redo your database?
Well, hopefully you have your SQL in another file that's how you populated all your data. Because otherwise, again, there is no undelete, there is no restore. You would need to run like MySQL dumps and run it on a daily basis, or however many database backups you want to do. There are processes and tools that allow you to do that and dump the database, like say every night at midnight. And then you always have at least one database snapshot that you can restore from if these were like real databases that you were using in real life. But otherwise, if you delete a database, it's gone, lost and gone forever, period. Right? So be careful. Right? Let me go ahead and use cburk. What tables do I have now? Well, I screwed everything up. Let me show the tables. I have no tables. I screwed everything up because I got rid of all the video game data. This is what SQL looks like. Right? At least I'm creating tables. We'll get to that later on. I'm inserting data in there so that I can have something to play around with. I'm going to select everything right now, cut and paste it, and change this to my login. Now, I want every single command in here to run. On a Mac, that's going to be Shift Command Enter, and it runs the entire thing. Okay? And it should have worked, right? Let's clear all this out. All right. There, now it worked. All right. All right. Forget about those, ignore those for now. But otherwise, lots of green check marks there. Everything worked. I'm going to go ahead and clear that. Where was I going with that? To execute the entire script that you've written, it's going to be Shift Command Enter on a Mac, probably something similar like Control Shift or Alt Shift Enter on Windows. In any case, it's this button up here in MySQL Workbench. This button over here only executes the current command. That's what I was doing before, which in this case is Command Enter. You only want to do one command at a time, right? You see down here that only that command that was currently highlighted is executed. Okay. All right. Well, let's see what we've got in here. This is a preview of R in CRUD, retrieve. I'm just going to select everything from the game table. And let's see what that looks like. Looks like a spreadsheet to me. Columns, right? And each one of these is a row. There's the game ID, the name, and the publisher ID. That corresponds to these three columns over here. And I've got a bunch of records, the exact same records, in fact, that appeared in your handout for homework 1. And I've got 20 records in here. Okay? Now let's start actually playing with that data. Okay? Again, retrieve, I want to save that fully for later on because it's a lot more involved. There's a lot more that you can do with selecting stuff out of the database because you're processing data. Inserting data, deleting data, updating data, that's really pretty straightforward. So let's go ahead and do the easy stuff first. So creating data. Now let me reformat this. CRUD, there we go. All right, creating data involves inserting records into an existing table. In new records, basically, into a new table. Obviously, you use the keywords, I should say, insert into, right? And I'm going to do everything over in MySQL Workbench here. But let's go ahead and insert a new game. So what's everybody playing right now? What did I got a new iPad, so I looked at what are the free games for iPad, and Polytopia. I played that for a few games of that. It was kind of like a stripped down civilization, so it was fun, but unfortunately, because it was a stripped down civilization, you got to a certain point and it was too quick. And so I threw it in. It was free. So what are you playing? Yeah.
Mario 3D World.
Insert Mario 3D World. That's an old one though, right? It's re-released on, okay, re-released on Switch. So insert Mario 3D World into the game table. Ooh, what did I just do there? Is that real SQL right there? Nope. It was a comment. Comments, universally comments, I believe, begin with a hyphen hyphen. Some SQL variants will be a hash or just a hash. In fact, it's allowing me to do that in MySQL Workbench. Some people will use both. So hash hyphen hyphen or hyphen hyphen hash. I'm going to just go ahead and go with hyphen. Okay? Yeah.
Is there a difference in comments, like design?
Um,
Or is it different types of comments?
No, not generally. There's not doc style comments. I mean, you could put in doc style comments, I suppose. I've not seen it though. No. So let's insert Mario 3D World into the game table. For that, I'm going to need 3 pieces of data: the game ID, the name, and the publisher ID. Okay. Insert into game. Then I need to specify the columns that I'm specifying: game ID, name, and publisher ID. Right. Values, and then I provide values for this game. Yeah, go ahead.
Do you have to name the table?
Yes, the game, well, not upper, table names and columns are case sensitive, but you can name them whatever you want. Now, I've followed this convention that it's all lowercase. That's just because that's how I originally designed this database. If I were to redo this, I would probably name it capital G, but there is no capital G game here, right? So I'm gonna have to do it with a lowercase g now. Okay. Values. Well, game ID is the primary key. Okay, 1. And name, Mario 3D World. Okay. Oh, hey, if that's a string, how do I denote strings? Double quotes. You could also do single quotes, in which case I believe, no, it doesn't become green. But it's okay to use one or the other. I like to use double quotes simply because it really drives home the fact that they are strings to me, at least. But as long as you're consistent about it, you can't begin it with a single quote and end it with a double quote. Okay. And publisher ID. Who published it? Nintendo, right?
Yeah.
So Nintendo. What's their publisher ID? To do that, I'm going to have to go to the publisher table. And oh, there, publisher ID of 5. So what can I do? I can put it in 5. Right? Now, we'll come back to that publisher ID here in a second. Is this going to work? Let me go ahead and execute this. Redx. Duplicate entry for 1 primary. What games did we already have in here? GTA 4 has a primary key value of 1. Primary keys are unique. They're the way that you uniquely identify records. So I can't use that key. Could I use 2? Nope. Can't use any of these. Oh, I could use 21, right? So I could do that, execute that, and it'll work. Green check mark now. And let's select all the games out again, and we see that it was successful. Awesome. Insert a game. Give me another game. Splatoon 2. That's all by Nintendo. Splatoon. Actually, 3 will be coming out next year. So into the games table. Game table. Excuse me. Table. Insert into game. Blah 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 blah. Copy pasta. Don't do that in general. Splatoon 3. Being released next year. I can't use 21 again, can I? Well, it's going to be pretty arduous So select out the game, see what's available, 21, okay, 22 is next available, so hard code that value, right? Now, in certain situations, it does make sense to hard code these values. For example, if I'm running an entire script here, and I'm inserting games 1, 2, 3, 4, 5, 6, 7, all the way up to 20 here, because I need to know what values those are so that I can associate them with something else, then it's perfectly fine to do this. If I don't care, because I'm inserting them on the fly, some things are auto-generated. For example, the primary key, I've set this database up to generate its own primary keys. Key management is actually a very, very difficult problem. Because what if I did it myself all the time? What if I said, okay, I'm going to go through, the highest key value that's been used so far is 21. Therefore, I can use 22. Between that, determining that 22 is available and using 22, another process might come in and insert a record at using value 22, right? And now it's no longer possible for me to use that value. So I'm not going to specify, in this case, the game ID, right? With auto-generated game ID, right? And when I execute that, green arrow or green check mark, and you can see that it automatically put in the next available key value. Key management is a very, very difficult task. It's one that is solved by using an RDBMS. Let it do its job, right? You're not going to do its job better than it, okay? All right, give me another game. Not Nintendo. Yeah.
What if you create a hard code to keep 25, for example, you want to start from 25 or start from 20?
I think that it will go to the next, so it'll skip a bunch, yeah. And internally, I think the database also goes ahead. That's configurable, though. You can change, depending on the database system, you can change how it does key management. But whatever the configuration is, let it do its job.
Is it like a short int or full?
It depends on how you defined it. I defined it as just a regular old int, which is going to be a 32-bit signed integer.
So it can run out.
It can run out. It'll start over again. If it runs out, then like 4 billion records is, or 2 billion records, that's all you got.
There's no more games to be made.
Yeah, exactly.
What if you wanted to create a database of all people on there?
Then you would need to use some sort of long, yeah, and then that's probably more than enough. 64-bit to complement integer. A question online is: will auto-generating keys work in all instances, or only in databases designed to generate its own keys? If you've got a database that does not generate its own keys, get a different database. I mean, the most stripped-down database that I know of, RDBMS, is going to be SQLite, and it does it. So I can't imagine a database that doesn't have that functionality. Right? Good question online. All right, so give me another game. Not Nintendo. All right, Among Us, that's popular, right? Insert Among Us. But somebody's got to tell me who the publisher is. Insert into game, name, publisher, ID. Actually, I don't know who the published it, so I don't care. Values, Among Us. Is this going to work? Fail. Red X. Why? No parent. A child cannot exist without a parent. No orphans here. I can't, this primary key up here, that can be auto-generated by the database, but I have to provide a name and I have to provide a publisher ID because I cannot exist without a valid publisher ID. Oh, okay, 5, right? That would mean Among Us is published by Nintendo, right? Is that, I mean, semantically that's okay data. Integrity-wise, that's a record in my database. It's just a wrong record. It's just bad data. There's no way for an RDBMS to determine that what you insert into it is wrong. As long as you insert it into a record correctly, that's all it cares about. So who published Among Us? Does anybody know? InnerSloth. There we go. Thank you. I was thinking there's always the sloth that comes up, right? InnerSloth. Do you see? Oops, sorry. Let's go publishers. Do you see InnerSloth here? No. So a child cannot exist without a parent. How can I get that record if I don't have it in the database? What do I need to do first?
apparently.
Yep. So, one, you need to insert the publisher, the publisher first. Right? So insert into publisher, name, values. Now you can go value there, and I think it will be okay, but just go ahead and be consistent. Even though there's only one value, we'll just still use values. InnerSloth. There we go. I'll go ahead and do that. Oh, and it was okay, green down here. Let's make sure that it's in there. And publisher ID, next one was 14. So I can go ahead and hard code 14 here, but again, that gets kind of tedious. If you've got some test data, like you will in your project, that's perfectly fine to hard code these values because you need them to be predictable. Over here, I don't care. I'm inserting stuff on the fly, ad hoc. I don't want to have to insert a record, then look up what ID did you get, and then insert another record. So what I'm going to do is I'm going to insert the game record, with using a nested query. Right? So I don't want to have to worry about that publisher ID. What I'm going to do is I'm going to put in, normally where I would put publisher ID, I'm going to put in another query to give me that publisher ID. Select publisher ID from publisher where, and this is what's called a where clause. It winnows it down to only the records that I care about. And in this case, where the name is equal to InnerSloth. Note here, did I use equals equals? Nope. So equality testing is just the equals. Not equals would of course be this, but that's not what I want here. Okay. Now let's go ahead and insert that. Green. Did it work? Yep. Among Us, published by 14, which is InnerSloth. Okay. All right. Lots of records there. You can also insert multiple records at the same time. So insert into game, name, publisher ID. In this case, it doesn't have to have the same publisher ID. You could be all over the map because you're going to specify an entire list of data at once. Publisher ID, values. Right? My first, give me a game, published by whoever. Somebody that already exists, though. Give me another Nintendo game. What?
I don't have a Nintendo.
Nobody has a Switch. Well, we're not a bunch of game players apparently. So, Splatoon 1.
I'm gonna say Breath of the Wild.
Oh, okay. Zelda. Is it Zelda Breath of the Wild? And published by Nintendo, which we already know is 14, comma, the second record. Give me another record. Mario. I think that's already in there, actually. Splatoon 1, published also by Nintendo. Now, of course, here I'm just using Nintendo because that's the only one that I know. You could have other stuff there too, but I don't know what.
Sonic.
Okay, Sonic. Sonic, published by Sega, which I think is in there. Yep, Sega is number 4, so there. Right? So 3 games, 1 query, all done. Operand should contain 1 column. Oh no. Values. Darn it. Oh, you know what? I think this opening one and this opening one should not be there. Note here that I'm going down to, I'm not having this one big giant line. I've gone down to the next line and then I've indented things over. Indentation is good, as keeping things aligned is good, but the consistency is the important thing. Okay. All right. Now are you okay with that? Yep. Now you're okay with that. So it wasn't. I had superfluous parentheses around everything. And now when we select from game, we see that those 3 games are in there now. Zelda, Splatoon 1, and Sonic. Okay. So you could do batch operations as well for create. Yeah.
You have to like
Well, wherever the cursor is. Right now the cursor is on a comment, so if I execute this, it doesn't do anything, right? If I execute this, it'll insert a bunch of duplicate records. Now I've got two versions of each one of those, right? Bad data or not? I'd agree that it's bad. So, but my database design is allowing it. If I wanted to change my database design to not allow that, I would need to put in what's called a constraint, a uniqueness constraint. And we'll talk about that when we get to database design, okay? Otherwise, I put all of those in so that you have the C of create data. Again, the selecting, the retrieval of data, we'll get into that in more detail next week. But update and destroy. All right. Let's go with update. All right. Let's see. You can alter existing records in a table using the keyword update. Right? So I don't know. Splatoon 1 wasn't really called Splatoon 1. It was just called Splatoon because they didn't know it was going to be a success and have 2 sequels afterwards, right? So let's go ahead and change that. That's not its real name. Its real name was just Splatoon. So update game set name equal to Splatoon. There. Okay. Should I execute that? Probably not. It was conceptually, what's it about to do? Oops. Did I say update this record right here? Nope. So conceptually, what's it going to end up doing? If that had been successful, every record in the game table would now be named Splatoon, right? You see the little red X. The little red X was the the database client saving me from myself. You read over here, using safe mode. You tried to update a table without a where clause, right? It saved me from myself. It's not going to let me do this because it knows, wait a second, you didn't quantify that. You didn't say that it was only one record or this record over here. You said change every record, right? And so no, I'm not going to allow you to do that. This would update every record, right? Safe mode prevents it. And one of the most common questions we get is, how do you disable safe mode? That is a huge smell that you're doing something wrong right there, right? You don't disable safe mode because it's saving you from yourself, right? How do I poke myself in the eye with a fork? You don't. That's the answer, right? How do you do this properly? Update using a where clause. Right. Update. Here, I'm just going to grab this. There we go. Where game ID is equal to, and I forget what the game ID is for Splatoon 2. In fact, or Splatoon 1. In fact, there are 2 of them, 25 and 29. So I'm going to go ahead and correct that first record, right? And let's select out of here. Game record 25 has now been fixed. Okay. Here's another way that you can play around with MySQL Workbench to get the same thing. You can double click on something, edit it, hit enter, and apply these changes. Before it actually runs, it generates the SQL code that I would have otherwise written. Right? Update cvirk game set name equals Splatoon blah blah blah. It's a little bit more fancy. And that's not how I would actually write SQL, but that's auto-generated SQL. Go ahead and apply that. Close, select from publisher, and now we see both of those have been changed. That one and that one. Okay. So always use a where clause. If you don't, safe mode will prevent you from doing it anyway, but if you don't, then, and safe mode is not on, then it's going to screw up your database. Say again?
Who knows where that's going to take you?
Yeah, exactly. There is no undo, there is no undelete. All right, what about destroy? That's the delete, right? So destroy. So those 3 duplicate records that I screwed up, I want to destroy all 3 of them. Right? Delete from game. If I do it without a where clause, again, safe mode is going to prevent me from doing that, because if I were allowed to do something like this, then it would delete every single record, right? Safe mode prevents you from deleting all records, right? And even if you did do this, it's not deleting the table. The table is still there, right? This doesn't delete a table. You need to drop a table if you want to delete a table. And that's something that we'll talk about when we talk about table design. But otherwise, you can't do this. So delete from game. Which ones did I want to delete? 28, 29, and 30. So where game ID is equal to 28. Green check mark, good. And you see that that first instance is gone, right? Zelda Breath of the Wind, the duplicate there is now gone. We still have, you see 28 is gone. By the way, to go back to your question before, does 28 now become available? Yes, theoretically, but it's not going to go back. It's just going to go forward until it needs to come back around, I think, and then it'll start reusing ones that are available, right? But of course, if you get to a point where you've got a lot of holes and you've got a lot of deleted records, and your performance will degrade, because then it turns into linear search to search for the next available key, in which case you take your database offline for a few hours and let it re-index. Re-index would be shoving all the indices back so that they're all contiguous and then resetting it. That would mean then that it has to also re-index anything that's affected by that, which can be a very, very intensive process. Might even take several hours, or depending on how many records you have. So that's called re-indexing. But anyway, we do have a hole here. 28 is no longer a record.
So re-indexing, you do it by hand?
Oh no, definitely not. It's a process. You just, depending on the database vendor, there are commands that you do and say, re-index. You could do a hot re-index where you don't take the database down, but then all of your users are now sitting there, and their browsers are spinning now because you're using so much intense. There's so many resources on the back end. That's why you tend to do it offline, or you have downtime, and then nobody's going to be able to get in. Let's get this done. It's going to take 3 hours, fine, but at least it's a contiguous 3 hours at 3 a.m. in the morning when nobody's there anyway. Or you have to take it, a copy, re-index it, and then hot swap it out, hoping that any new records that get created are brought over somehow. Question?
Wouldn't creating a list of available indexes kind of fix the issue?
It could, if that's how the database works. Like, I think it'd probably be just as expensive to maintain what is available than just maintaining the next possible one. That's how it does, the next possible. There are other strategies that you can configure the database to do, but we don't have that level. I don't even have that level of access to do.
Is it like up to type of database that you're using?
It definitely depends on the type. So MySQL, Postgres, they're going to offer different algorithms under the hood, and different configurations.
And like the SQL queries in the right, it's just the way you speak to them.
Right, that's just the CRUD. It's just the speaking back and forth. In fact, I'm not going to introduce any vendor-specific SQL at all. Any SQL I give to you is going to be cross-platform. It doesn't matter if it's SQL Server, Postgres, SQL, Informix, whatever else IBM has. Informix and I forget the other one. But anything that I introduce into this course is going to be universal. Right? Now, vendors like to put out their own additional syntax. Hey, we've got this new cool feature over here. Come and use our database and you can use it. Then you build a whole bunch of code on that, and now you've got vendor lock. Because if you ever want to go over to a different vendor because they're cheaper, well, now you're rewriting all your database code because that vendor doesn't support those not proprietary, but those vendor-specific functionalities. And that's why I'm not going to show anything like that to you. But anyway, delete. Here's another cool feature from game where game ID in, I want to delete both of those records at the same time. Or actually, here's another way to do it. Is equal to 29 or game ID is equal to 30. Right? You can use keywords or, and, right? Or you can do something like this. Here's an in clause, 29, 30. Right? This is a set where the game ID appears in this set over here. That allows you to do nested queries on delete statements. Let me go ahead and try. I believe safe mode will allow me to do this. Yep, safe mode allows me to do this because I specified actual IDs. Now they're both gone. Yeah.
So you could do or and you can do and. Would and make it so that, like, no game has two game IDs. So, like, would it make it so that, like, it wouldn't delete either of them?
That's a no operation right there because it doesn't even make sense, right? You're right. The game, well, got to get the syntax right. Where game ID is equal to 29 and game ID is equal to 30, there can only be one value, right? So this would be, no such record would do this. And this will be perfectly fine, green check mark, 0 rows affected. Right? Ooh, 27, oh, okay, no, that's different. Right. So you can have successful things that don't have any effect on your data. Right? All right, again, no undelete, so be careful. I'll put this in the notes. There we go. All right. The R, and we'll only get into it a little bit today, but retrieve. Right? There's a whole bunch of ways that you can do this. The way that we've been doing this so far is you can use a wildcard to get every column in a table. Right? And the examples that we've done up to this point are going to be, select star from publisher, star from game. Let me get rid of this. Keep running into that. Right. There we go. The star there is a wildcard. The wildcard, in other words, star. And somebody asked where this came from. I meant to look it up in the interim between the two classes, but I was posting grades instead. That's probably more valuable to people. And I meant to look this up, but I believe they said, no, did that come from Unix? And I think Unix came after 1970, so if anything, Unix borrowed it from SQL, but then I think they both borrowed it from mathematics. This is basically the clean star, clean, right? And it's used in regular expressions, and it's used in mathematics. This is the clean star, where it matches anything. It's a wild card. It'll match everything. And so this gives you all of the columns. When we executed this, we got back the game ID, the name, and the publisher ID. Right? Well, there's nothing to stop us from modifying that. What if you don't want all the columns? What if you just want the title? Select the name from game. When I do that, I only get that one column. You can, of course, provide multiple columns. Multiple columns are separated by a comma. So select name and publisher ID from game. I should space those out. There we go. White space in general doesn't matter, but you should use it to make your stuff more readable. And in fact, you can change the order. Columns are unordered. So you can specify an order. What if I want the publisher ID first and then the name? Well, it doesn't. That just makes it nicer if you're trying to look at it that way. It doesn't have anything to do with the data, right? You swap this column and this column, all the rows stay with each other, so it doesn't matter. Okay? Yeah.
I forgot my question.
That's all right. We'll do some more here. Name is not a very good column name, is it? In fact, you can see name, it's blue here. It's a keyword in SQL, but since I'm using it as a column name, it's not coming up as a keyword. Yeah.
Can you use spaces when deciding what your columns are going to be called? Like publisher ID, take that.
No, you cannot. No spaces. That's why old school SQL, you'll see underscores everywhere. No spaces, just like variable names. Well, I take that back. There are ways that you can do it using backticks. So here's how you create a table. Table foobar. There we go. And int column foo int. There. That should be there. There. Now it's happy about that. It's not going to be happy about that. But I can escape it and it will be happy about that. It's red now. Those aren't single quotes. That's called a backtick. And if you look at your keyboard, the thing below the tilde is a backtick. And a backtick is a way of escaping things. Ugly, ugly way of doing things. I would not recommend that you do that, but you can do something like that. Right? So no, don't try. Yeah. You could name a column name or a table name null as long as you backtick it. I would not recommend that. No. So in past semesters, we have had similar projects where people make an invoice system, and invoices have orders. Order is a key word, so everybody wanted to name their join table order. And I didn't anticipate that because I never would have done that. I would have done something else, but everybody tried to name their column order, and that's a key word in SQL. And I didn't talk about the backtick that year or something, and so nobody knew how to do it. And how am I doing this? Choose a different name. Order is a terrible name. Choose an invoice, right? That's what it is. But anyway, you can also alias these. Like I said, name is a terrible column name. So I want to rename it. It's actually a title, right? As game title. And for the purposes of that query, the result that I get back here now says game title. Now it doesn't change the table. You can alter tables. That's completely different syntax. That's alter table. And then you have to specify how you're changing the table. Again, I wouldn't recommend doing that. But you can alias your columns, right, using the as keyword. Let's go. Now, generally, if things get too, you can alias something as the same thing, publisher ID from game. There we go. It can get quite long, and so when queries get too long, you can go to the next line. White space generally doesn't matter, but I do indent over so that this is the same query. This is not a new query that's starting over. I have consistent indentation here. Some folks like to go even more indentation and then bring out the keyword over here. That's going a little bit far in my book. This is how you'll see me doing it. How you do it, it's up to you. All right, find your own style or find a style guide online. It's less universal than you'd think for SQL. But find a style guide if you want, find your own style. The key is just be consistent about it, okay? I'm gonna go ahead and go with this style. You'll also find that a lot of, let me go ahead and cut and paste this. Yeah, go ahead.
Is there an auto format?
I don't think so, not with my SQL workbench. There might be an auto formatter online. SQL auto format. Where you can, cut and paste SQL. You can post it later on. A format. Hey, SQLformat.org. Who would have thought? I don't know. Let's find out what it does to this thing.
There's another one very much nicer that I used to use before I can post it later.
Oh, hey. Now, why did it do that? That's going to save me some typing here. I don't like that formatting, so I'm gonna encourage you to post that and not use what I just showed you. This is actually what I was going to talk about. The old school way of doing SQL was to have all the keywords all uppercased. Select name as and from. They are all uppercased in this example. Think back to 1970 when COD was working on this stuff. What kind of monitors did they have back then? green screen monochromatic monitors. So if you only have one color, green or white on black, then it makes sense to offset keywords in all caps so that it's more readable that way. And I would agree that if you are color deficient, then yeah, fine, go ahead and use these all uppercase. We no longer live in that world though, right? We have, as you can see here in MySQL Workbench, we've got nice colored formatting here. That offsets keywords. Now, sometimes it fails because name is a keyword, but it's also a column. You can always, backtick those if you really want and get another color, right? But otherwise, we live in the modern world where we've got color-coded formatting. So there's no reason to continue doing this old school way. And the reason that you would not want to do that is because you're always hitting your pinky over to either the shift button, over to the underscore, or the shift button, and then you're trying to type a whole bunch of words. Or you're putting on the caps lock with your pinky finger again, typing, then taking it off. Save your pinky finger, right? The only thing that a pinky finger should do is QAZ, and that's it. Yeah?
Was it like the same for like assembly and
Yes, I think most assembly languages are going to be case insensitive. SQL is case insensitive on their keywords, case sensitive on strings, column names, and table names if you have a decent setup. It used to be that many years ago, CSE was configured to be default of case insensitive on virtually everything. And that's not a good world to live in, including strings. So foo and capital F foo were the same string by default. But I would not suggest this old school way of doing things. Do it the way that I've been doing. Right? You'll save your pinky. Your pinky finger will thank you. Okay? Any questions? Otherwise, you can do the same thing with select everything from publisher. And I'll go ahead and execute both of these. And you see that, oh, come on, why didn't it do both? Should have done, I should have two tabs here, but I don't. All right. Oh, I probably didn't. It's my keyboard. It's my Mac keyboard. It's 4 years old. The keyboard is failing for the third time. It's the butterfly keyboard, right? Hopefully they retired that. But there. Now I got it because I really pressed down with my pinky finger. Anyway, here's the game data. Here's the publisher data. But that was two different results. How can I bring these together to produce a result that looks like what we originally had? The CSV data, where I've got a game name and its publisher name in one report. I'm going to have to take table A, publisher, and table B, game, and I'm going to have to join them together to give me a new result. And that's where we'll start next time. Okay? All right, have an outstanding weekend.